Good afternoon, and welcome to Hand-Wavy Chemistry. When I get asked chemistry questions, there is one phrase that has a habit of popping up over and over again. And that phrase is, I tried asking ChatGPT. Now, you can probably assume that because the person is now asking a human, they're not satisfied with the answer the AI gave them. And in this video, we're going to look at why it is that artificial intelligence struggles with answering chemistry questions. Now, I don't intend for this to be a gotcha video where I ask the AI niche questions about highly advanced topics and then go, actually it should be this. For example, if I were to ask it, what is the hybridization of oxygen in water? I would expect and accept the answer of sp3. This is also what is written in undergraduate textbooks. Although it is interesting to note that there is a Wikipedia page dedicated to the bonding of water, and if you push these AI chatbots, they will admit that sp3 hybridization doesn't explain the experimental measurements associated with the energy levels in water. But where I will hold them accountable is when they perpetuate common misconceptions that are not part of the textbook. For example, if I ask the question, what does the molecular orbital diagram for methane look like? Both Google's Gemini and ChatGPT give incorrect answers. ChatGPT starts off by saying that the carbon is sp3 hybridized, which is true, but it's part of valence bond theory, not molecular orbital theory. It then creates molecular orbitals by combining these 4 degenerate sp3 orbitals into 4 degenerate sigma bonding orbitals and 4 degenerate antibonding orbitals. It is mixing and matching between different theories to give an incorrect answer. Google's Gemini also starts out down this track by saying, hey look, carbon is sp3 hybridized. Then when it mixes the orbitals, it actually mentions that one of the orbitals is lower in energy than the other 3, even though nothing it said before this would actually support that conclusion. And it gives links and references to other sources which also show that you do not use sp3 hybridized orbitals when constructing a molecular orbital diagram. Now, in order to understand why it is that these generative AIs are perpetuating common misconceptions, we need to talk about how they work. Generative AI models take text, images, videos, audio, and other data, and then they study it to build a model that is looking for patterns in the underlying information. You can think of it as being like a predictive text on steroids. Let's say you and I are going to write a story together, and I start out by saying, once upon a, you're going to say, time, because that is what we expect to hear. So when these AI models go out, if they keep seeing incorrect information, they don't know that it's wrong, and they're going to incorporate it into their models. So common misconceptions get reiterated as though they were fact. Another thing that can happen is that it can give a different answer each time. Let's go back to our story example. We started out with once upon a time. If I say there was a and leave a blank, there are many, many options you could put into that space. And this happens with generative AI as well. You get different answers to the same question. For example, here is a problem that I recently put to both Gemini and ChatGPT. 10 cubic centimeters of a hydrocarbon is exploded with an excess of oxygen. A contraction of 35.0 cubic centimeters occurs. All volumes being measured at standard atmospheric temperature and pressure. On treatment of the products with sodium hydroxide solution, a further contraction of 40 cubic centimeters occurs. deduce the molecular formula of the hydrocarbon. And a question like this is the type that students will often go to a chatbot with because they're not sure where to start. Now, the first time I put this question to Google's Gemini, it gave me the answer, "This question is impossible because 40 is greater than 35. Now, it is entirely true that 40 is greater than 35, but this question is not impossible. However, there are a couple of things you need to understand to make it easier to answer. Firstly, the products from the combustion reaction are going to be carbon dioxide and water. The water could either be water vapor or liquid water, and you must assume that it is liquid water, otherwise that first initial contraction doesn't make sense. The second thing you have to keep in mind is that 1 mole of a gas occupies the same volume regardless of what the gas is. So where the question says 10 cubic centimeters, it could just as easily say 10 moles of a hydrocarbon, which means we can relate volume directly to quantities. So, knowing that AI can give different answers to the same question, I let Gemini have another go. This time, it correctly identified that the volumes of the gases can be directly compared, and that because we had 10 cubic centimeters of hydrocarbon and 40 cubic centimeters of carbon dioxide produced, there must be 4 carbons in each molecule of our hydrocarbon. So it is C4H, we don't know yet, but it kept the water as a gas. And as such, it ran into problems. The initial contraction didn't make sense, and it ended up with a negative value. At this point, it just shrugged and said, well, if we take the absolute value, we now have a positive value, and I can calculate how many hydrogens there must have been. And doing so, it got the answer C4H6, which is not correct. Seeing the improvement from the first to second attempt, I gave it a third attempt. This time, it answered beautifully. It even directly mentioned that the water could be a gas or a liquid, and showed that having it as a gas didn't make sense. Then, by assuming that the water formed was liquid, it found the correct answer of C4H10. I then posed this question to ChatGPT. On its very first attempt, it correctly identified that the unknown hydrocarbon was C4H10. I'm not going to show you all of their working in case perhaps you want to have a go yourself. Now, I mentioned that these generative AI models look for patterns and study data and existing texts. And this actually led to an amusing situation recently. A student had been set the task of analyzing an NMR spectrum. And to help them out, the teacher had also given them a paragraph of hints. However, they had put the wrong spectrum with the hints. So, as written, the question couldn't be answered. So we just ignored the hints, analyzed the spectrum, and came up with an answer. But if I took that paragraph of hints and put it into one of these generative AI models, it actually knew what the question was supposed to have been and gave the expected answer based on the hints without having ever actually looked at the NMR. Which leads into another problem with generative AI. Sometimes they ignore information. For example, I was writing a series of questions related to nuclear fusion. And so that students couldn't just look up the answer, I was changing some of the values. For example, increasing the mass of a proton. So I wrote a question that went roughly like this. Assuming that the mass of deuterium is X, and that the mass of helium-4 is Y, how much energy is released when 1 gram of deuterium fuses into helium-4? The AI did a really good job of setting out the problem. It made it look like it really understood. It showed the different values, and then it gave an answer that was different to mine. And it had done such a good job on the layout that I started to question if I was the one that had made a mistake. So I rewrote the question slightly and put it into Wolfram Alpha. Now, Wolfram Alpha is not a generative AI. Rather, it is an answer engine that attempts to give factual answers by doing computations and calculations. It even starts out by saying, this is what I understood your question to be. So that you can kind of go, yeah, that's what I wanted, or no, I need to rephrase it some more. Wolfram Alpha gave my answer. So I went back to the generative AI answer, worked through it again, and realized that the answer it was giving was actually the real world answer. It had done all of this work templating the answer using the numbers I had given. Then at the very last minute, it had switched in the real values and given the actual real world answer, not the answer you'd get using my values. Now, generative AI aren't just restricted to text responses. They can also generate other media, such as images. And you could see how someone might wonder, what does this molecule look like? Or what is this crystal structure? And could pose it to one of these chatbots. So I recently asked Google's Gemini to draw the crystal structure for magnesium hydroxide. This is something that can be easily found online and is well known. And this is what it generated. Absolute garbage. Because what it's doing is it's looking at different words and assigning them weights. It's looking for patterns. It's seeing that word crystal structure and thinking about, well, what do crystal structures look like? It's seeing magnesium and hydroxide, and so it's labeling some of those atoms as appropriate. But what it has actually made is complete nonsense. And what makes these chatbots so detrimental to someone trying to learn a hands-on science like chemistry is that while it's easy to look at this picture and go, it's garbage, it's harder to look at the pages of text with well set out equations and spot this is equally invalid, unless you already know the answer, in which case, why are you asking a chatbot? Hopefully in the future, these generative AI models will get better at answering technical questions. And there are efforts underway to try and train them. But we'll have to wait and see how those turn out. I hope you have enjoyed this video. And if you have, please make sure to like, subscribe, and share it with your friends. And if there is a topic you'd like to see covered in a future video, please put it down in the comment section below. Thank you, and I hope you have a wonderful rest of your day.